All right, we're going to go ahead and start with number 6, the one that's like inscribed. I'm not going to write out the whole problem just because it gets to be a lot writing them all out. Page 231.
Thank you.
So we have a rectangle has its base on the x-axis and its upper two vertices on the parabola y equals 12 minus x squared. What is the largest area the rectangle can have and what are its dimensions? So basically, just a rough sketch here.
I was looking at number 5, so I was like, wait, what? So I didn't catch any of that.
So basically, I've got this, and then I've got a rectangle like that. So I know that this point obviously here has to be 12 because the graph has been shifted up 12 and it's reflected. So what is the largest area the rectangle can have and what are its dimensions? So I would say let's call this x and this x over here. So in total we've got 2x. Then this point here is at x and 12 minus x squared.
So that little, what's it called? Is that like a vertex, right turn? I don't think that's the right turn.
What are you talking about, this?
Yeah.
Yeah.
Oh,
it is.
okay.
Yeah. Technically, like squares, rectangles, triangles, all of them have vertices.
Okay.
It's just like the corner points of them.
I just wanted to make sure I was using the correct term.
Yeah. So, what do I know about the area of a rectangle?
So that's length times width.
It sounded like you were going to keep going.
Nah. Is the length, like, is it generally like a cursive L? Because I think I always remembered seeing it as a cursive L.
I mean, most people do that because otherwise it looks like a 1.
Oh, my L's always have a little at the end of them.
So,
then it
yeah,
kinda
it
looks
just kind
like
of depends.
My parentheses.
Yeah.
is-
It's just kind of like the easier way to do it. It doesn't really, like, make that much of a difference. So, area is equal to 2x times 12 minus x squared. So I would go ahead and distribute before we take the derivative. So a equals 24x minus 2x cubed. So then what's the derivative?
24 minus 6x squared.
Gotta make sure you don't earn another quiz for y'all.
Tomorrow would actually be tomorrow.
Tomorrow would actually be tomorrow. That is very true. Wouldn't get it wrong this time. All right, so then
I just let you go with it because it would make the prank even funnier.
Yeah, it did, for sure. Except for it wasn't watched until later, so.
Well, that was the whole point of me not telling you about it. Because she actually believed it.
True. And so again, when I take the square root, obviously it can't have a negative length, so it's got to be the positive version. So x equals 2. So now I just go and plug it in. Basically, length is 2x. So that is 2 times 2, which is 4. And then the width, 12 minus 2 squared is 8. So it's actually interesting. The picture is actually drawn wrong based on where my length and width are coming from. But obviously, length and width can be used interchangeably. It does not matter.
Honestly, though, I'm used to squares having the most area. So the fact that it's actually a rectangle is fascinating.
So we found length, found width, then just multiply them to get our area, and they did not give us units in this one, so just put units squared. They don't technically even put units on theirs, but I think it's good just to have the habit. Jeez.
I used to be able to do that.
I mean, I still can, but like,
If I try hard enough, I could today.
it's rough, but anyways. All right, number 10. So getting into some actual
But like that one wasn't real.
questions here. Well, like legitimate word problems. All right, so again, not going to write out the whole problem because it's kind of long, but
It's not drugs like in stats.
true. A 216 meter squared rectangular pea patch is to be enclosed by a fence and divided into 2 equal parts by another fence parallel to one of the sides. What dimensions for the outer rectangle will require the smallest total length of fence? How much fence will be needed? So basically, I've got a fence.
I wasn't crazy when I said that I think understanding the problem will be the hardest part.
We have a rectangular pea patch.
Okay.
And it has an area. No.
Rectangle.
216 meters squared, yep. So an area of 216 meters squared. So basically, then it says that there's a fence that splits it in 2, and it's parallel to one of the sides. So my options are either that it goes like this, or that it goes like this. Okay, and that's basically the 2 ways. Now, I think it's pretty logical to figure out which way it's probably going to be going to have the least amount of fencing used, but I just want to point out that there are 2 options. I'm getting rid of the one that it's not.
That's for Virginia, right?
Right. All right, so basically, I don't know. I'm going to call this, I don't know. We're just going to call this W and these length. Doesn't really matter. Just going for it. All right, so
I find it interesting that it says that it's parallel to just one of the sides. Isn't it?
no,
kind of
technically
forced
2.
To be parallel to 2?
Yes, just a little misleading there, I guess. But if it's going to be parallel to one, it has to be parallel to the other. So.
No, it's not a rectangle. And then what do we do?
Hope for the best. Area is length times width.
Are you okay?
I just couldn't get it to write. So I can solve for one of the variables. So W equals 216 over L. Now, ultimately, I'm going to be looking for stuff that deals with perimeter. So obviously I need that formula as well. So perimeter is hold on. In general, perimeter is 2L plus 2W. However, in this particular case, it's actually 3L plus 2W. So I'm going to take this and plug it in over here. So this is 3L plus 2 times 216 over L. So that's going to give me 3L plus 432. And I'm going to write L to the negative 1 for the purpose of getting ready to take the derivative. Derivative of P is
L plus, not L either. Okay.
I was starting to wonder. Virginia, Josh is about to earn y'all another quiz.
Minus 432 L to the negative 2.
Oh, good. You got that part right. No quiz. All right. So then, equal to 0.
I forgot the prime too.
So negative, I think I wrote it and it like deleted itself, but
Oh, mine just didn't exist.
well, yours doesn't just delete itself even if that's the case, but mine does sometimes. So then I'm going to divide by the 432. Negatives will cancel. So I end up with 1 over L squared equals 3 over 432. Flip the fractions. L squared equals 432 over 3. I feel like that should be able to be reduced.
Yeah, I was gonna. Well, it definitely will be. But I was gonna say, couldn't we reduce the 3 over 432 to like
Well, yeah.
1
That's
over
why I was saying, like, we can, pretty sure we can reduce that.
Yeah.
Yeah. So, I was just going, and then I was like, I bet that will reduce. So, L squared equals 144. So, L equals 12.
I like that.
So, now I shall take this and put it up here. So, I get W equals 216 over 12. Do you happen to know what that is? I don't just off the top of my head, so it's okay. Obviously, no, it has to be bigger than 12.
Right. I'm gonna guess 18. Let me check. It is 18.
I think you had already looked. No, I'm just kidding.
No, I just pressed enter right after I just said it.
No, I was just kidding.
Sure.
All right, so the width is 18 meters.
Oh, I forgot my units on the line.
Oh, yeah, I did too. Look at that. I think it's just because, like, I'm solving for these things, and then when I go to, like, write the answer, then I'm like, okay, I can put units on them now. So we have those things that we need, and then the perimeter is 3 times 12 plus 2 times 18 is 36 and 39. Nope, 38. 490. Nope, not 90. 72.
Yes. I was worried when you said 38. I thought I did something wrong, and I had 36 plus 36.
Yeah, I was like, wait a minute, that's not right. What was I doing? Oh, I was doing it as if it was 19. I was thinking 19 for some reason.
I was starting to think that 2 times 18 was 38.
All right, so that's the total fence needed on that one.
I just heard a child cry for a help.
Probably one of the kids that's mom works over there. Oh my goodness, what is going on? Ah! Everything is tumbling.
I don't know. I think that was the papers moving.
All right, 14.
Oh, Virginia's missing out.
She might be able to hear it. Probably not.
I hope so.
She's gonna think we're crazy.
I'm sure she already thinks I'm crazy.
All right, so this one, the height of an object moving vertically is given by this equation that I just wrote here with s in feet, t in seconds. Find A, the object's velocity when t equals 0, B, the max height when it occurs, and its velocity when s equals 0.
You know, I don't understand how Virginia can do any problem with t and plus signs. Because they literally look the same when she writes them. Now, of course, if she's going to listen to this video, then she'll hear me call her out on that. But oh
True.
well. Hopefully she fixes it.
Velocity when t equals 0. So, what's the velocity equation?
Hold on, I need to write the up t part of it. Negative 32 t plus 96. I think.
So then, when t equals 0, v of 0, negative 32 times 0 plus 96. 96 feet per second. I never realized how loud they are out on the playground.
I don't think they ever realize how loud they are either.
How much screaming do they need to do? That just seems excessive.
They have absolutely no sense of vocal preservation. They don't care. They just scream until they can't scream anymore, and then they keep on screaming.
Just heard one of them scream, "Daddy!"
I can't tell if they're just getting quiet or if they're getting farther away.
What is happening? That doesn't... Oh, that doesn't go with that problem. That's why I'm tripping. It's front and back.
Oh no.
I was like, that's not even the same problem. Okay, anyways, so we take the velocity equation and we set it equal to 0.
Right. We put 0 in for t in the last one.
Yes.
I was kind of confused. That happens.
So then we solve for t. So t equals 3 seconds. Now that has to go into the position equation to figure out what the max height is. So s of 3 equals negative 16 t, nope, 3, I can't talk. Negative 16 times 3 squared plus 96 times 3 plus 112. Would you like to type that in and give me an answer?
Yeah.
Nah, we'll be sitting here for a real long time. I don't even know.
Did you just snort?
No, I like put my tongue on the roof of my mouth and it just was like, I don't even know.
Okay, so does 256 match up with whatever your papers say?
Yes.
Okay. Because that's what my calculator said.
So 256 feet. So the max height is 256 and it occurs at 3 seconds. It's like they didn't even tell us what this object is. I feel like whatever it is moving very quickly. Like, yeah. I don't even know. Okay. C. Velocity
More.
when s equals 0. So we're going to set our position equation equal to 0.
Makes sense.
Make sure I have that actually written correctly.
Can we just take out a 16 so we can understand it better?
How about a negative 16?
That works too.
Okay.
Just throw it out there. We don't have to worry about it.
Just get rid of it.
Yep.
So obviously
This is
that's
dumb.
disappearing. So then I need to factor what's in the parentheses. Josh, you got this one.
Right. So, do you not understand it?
No, I do. I want to make sure you do.
Yeah, so, I think we have a positive 1 and a negative 7.
So t minus 7, t plus 1.
Yeah, something like that. I agree with that, child.
So t equals 7 or t equals negative 1. iPad is glitching. Stop that.
I think I understand how your iPad feels. Oh,
Now.
I know what happened. I glitch a lot.
What's the problem?
Negative.
Bye-bye.
I bet you Virginia wouldn't have gotten that.
I think she would have had that under control. So now at that time, we want to know what the velocity was. So in our velocity equation, negative 32 times 7 plus 96. Is negative 128 feet per second.
Put in the calculator. Yeah, that thing is moving pretty fast.
Okay. Number 18. Now, I am going to draw the picture that goes with this one to the best of my ability because it's helpful. Bless you.
Thanks, I guess. Just one singular cough. Oh, I see why you're drawing it now. I might have to draw that too. This silly little shape. We have like 1,000 other silly little shapes to add on to it or something.
It's just easier to have the picture so you can, like, draw on it.
Yeah. I think I did it decently.
You already done?
Yeah. I don't have to make sure all the lines are super straight.
That one is not straight.
Oh.
It literally fixed it and it wasn't straight. Like, rude. Okay.
I just want it to be a little different.
All right, now, I love how it says not to scale. Like what?
Well, I mean, I don't think that's quite 10 inches.
Yeah, but like you can still have something scaled. Like, I don't know.
I don't know, maybe they just didn't want us to get the wrong idea or something. Not even sure what that could be.
All right, so all these little thingies are X's. Okay. I think that's everything from the picture that we need. So,
Close enough.
now we can actually read the problem.
Design a box with a lid.
A piece of cardboard measures 10 inches by 15 inches and two equal squares are removed from the corners of a 10-inch side as shown in the figure. Two equal rectangles are removed from the other corners so that the tabs can be folded to form a rectangular box with a lid. Write a formula.
I hate this problem. We have to turn the page.
I was like, what did it do?
It made me turn the page for the rest of the problem. Math books should never do that.
Yeah, the first time I ever did this problem, I didn't realize it continued on the next page, and I was like, what's the question? And then I was like, somebody was like, flip the page. I was like, oh. Write a formula V of X for the volume of the box. All right, so what is, obviously, generically, the volume of a box?
Length times width times height.
Okay. Now, what's the height in this case?
X.
What about the length?
Give me a moment.
Perhaps
We'll
let's
go
do
with
this.
10 minus, like, 2x.
Okay, that's the width.
Yes, I know, but I can't length right now.
All right, so if I essentially cut this in half, I have the base with a tab. If I did this, I have the lid with a tab. The lid has to be the same size as the base, correct?
Mm-hmm. So, like, that would be like 7.5 minus 2, or 15 over 2, however we want to call it.
Minus just X, because I'm only taking out one X in half.
Yeah.
And then over here I have just an
Okay.
X.
Thank you. Thank you for your assistance. This is why.
Anytime.
This is why I need a math teacher. I may be decent with math, but I can't math.
I am tripping with this stuff that I have on multiple pages. Throwing me for a loop. Okay. Anyway, so
I
now...
understand why it said it's not to scale. Because maybe, like, the height is the biggest one or something.
Could be. Alright, so...
Oh, I didn't have my following formula.
7.5 minus X times 10 minus 2X times X. Oh.
Are you okay?
Yep, it just glitched. Alright, so that gives me 75 minus 15x minus 10x plus 2x squared times x. So that gives me 75x minus 25x squared plus 2x cubed. So that is the formula for the volume of the box.
Maybe this problem isn't so bad after all.
Alright, we're kind of going to skip B because we kind of end up doing it within C because it's just basically graphing it to find like the domain. Yeah, so anyways, we're just going to kind of skip that. So
this one is telling us that we have to use our calculators.
So C is, it says use a graphical method to find the max volume and the value of x that gives it. So you're going to type in that equation.
We go to finding the maximum. We do the boundaries and whatnot. So we want to know what V would equal.
Yeah, well, I want to know the max volume. So I need the y is going to be the max volume and x is going to be at what's like chunk that we cut out. Like, where does that occur?
Okay, so X is how many decimal places do you want me to go?
Let's just say 2, I guess.
1.96 inches. And Y is 66.02 inches cubed.
All right. Then they want us to confirm this analytically. So right now we've done it graphically, but let's say hypothetically you did not have a calculator. Well, we may still need it technically to answer them to get the decimal, but let's say you couldn't graph on your calculator. Let's do it that way. All right, so we need to first and foremost take the derivative of v, which would be what?
75 minus 50x plus 6x squared.
Now I set this equal to 0. Suggestions?
Wait for the storm to pass. No, we can't do that. Reorder the stuff.
Okay, I can. I don't need to, but I can. If you can't factor this, what would your next thought be?
What is this sign? Quadratic formula.
Are you looking for the sign because you don't remember the quadratic formula?
Remember it. I'm just looking for the quadratic formula sign because I just
It's not in here.
didn't know where it was.
Alright, so this is going to be 50 plus or minus the square root of 50 squared minus 4 times 6 times 75 all over 2 times 6. Now you need your calculator. I want a nap.
You want to nap?
Yes. But I'm helping them at basketball today, so I can't nap.
Okay, I'm just gonna say, for now, hold on. 50 plus or minus the square root of 700 all over 12.
I'm just gonna wait till you get your 2 answers.
Okay. Oh.
I would just use the fraction thing and do this all at once. If it were me.
See, this is why you're the teacher and I'm the student.
Comes with practice.
Like we're only gonna have answers, darn. Okay, so x equals 6.37. Do we want units?
Don't worry about it for right now.
Okay. X equals 1.96.
So what do you think?
I think based on what I saw on the graph, the 6.37, that's like after it went under 0 and then started coming back up. So that one's one of those
Well,
extraneous thingies.
What else do we know about this? Can I cut 2, let's just say 6s out of a 10-inch side? So, box isn't this big. So it has to be that one. Alright, there's one more, but I think we'll save it for tomorrow because there's not that much time left. And
then maybe Virginia will be present for at least one more.
yeah, it's not like super hard, but it's just like a weird problem. So we'll just save it for Minata. Do you want any problems? They aren't due tomorrow.
It's just a really weird question to ask. Sure.
Virginia's gonna be like, why did he say yes?
That would mean she wasn't paying attention because you said they're not due tomorrow. So.
Man down. You won't be able to do 25 yet if you do decide to start them.
Oh no, even farther.
And it's a good problem, that's why. But I gotta remember, we still gotta do 26 tomorrow.